Hello everyone, welcome to VLSI Path. This is part of our static timing analysis series, guiding you from basics to advanced concepts step by step. Today we are going to discuss what are the stages of STA in the ASIC design flow. So let's dive in.
So when do we check the STA? As I said, it won't perform only on the single stage. We start it very early in the design, and then like the checks will becoming more accurate as we go lower in the VLSI design flow. So first stage is the pre-synthesis. When we have the RTL code, we don't even have the netlist. So there we define the delay corresponds like what will the approximate delay for the clock also we are giving, considering the skew, we are considering the cell delay, we are giving the hashtag after this time output will be available, right? That's the high level netlist we have, high level Verilog code. The next stage is post synthesis. Once we have done the synthesis, then we have the gate level netlist. There also we perform this timing analysis. Okay. Then pre-layout. Pre-layout meaning that we have the floor planning or the placement info. We have not placed the cells, but we have the info, and that we'll keep in a file, and then there we perform the timing analysis. Like if we have the shape of these blocks and these blocks will occupy this much area, how will be the interconnection between these blocks. So those info when we have, then we again check this. Then in the post placement, when we place the standard cells, we have the exact location of the standard cell. We know that delay from the dot lib. Then we again perform the STA. Then post CTS. Once we have completed the CTS, then we have the clock tree data, right? So after that clock tree skew information we have when we have the different skew groups. So the clock from the main source it is coming to different groups. Then what will be the input delay of these clock groups? That also again will be included in our analysis. So it will be becoming more accurate. Then there's a post routing stage where we have done the data routing also. We have interconnected all the cells available. So after this stage, it's like almost all the connection we have made. Now we again extract the .spf file and then we'll go for the sign of STA. Sign of STA meaning, as I said, in all the stages we check the timing analysis. So if something, let's suppose something here violating at this stage, so it's not like we will wait till the sign of STA. We will fix it at this stage. And the sign of STA is a stage where we can say that my design is ready in terms of timing for the tape out. Okay. So for the pre-synthesis, you are using the RTL code, that's the Verilog code, SDC, if any constant we define, .lib file, that text file, and then we are checking the STA with respect to these. Some extra file will be there. I'm just mentioning the important files. Netlist, then here the RTL code will be changed to netlist, meaning the gate level netlist. This is for the post synthesis stage. In the pre-layout, we are including this floor plan placement info. Again, then the post placement, when we have placed this, we are including the clock tree info. In the initial stage, we have the clock tree information, right? What are the clock groups you are going to use? What will be the approximate delay of these clock groups, right? But what after the post in CTS, we have the clock tree report, meaning we have the exact data. Info meaning we are approximating that this will be the delay, this will be the location of these nets or these cells. But when we have the report, it means we have the exact data, where we have placed them, where we have routed them. Then here again, we are taking the final clock tree data, and the post routing, we have the routing details also, the data routing. So we are extracting the .spf file. And post routing, we will include some like crosstalk induced delay also will be there, right? So the clock tree, clock net and the data net will be there. So because of the cross coupling or the crosstalk, the clock net always be aggressor net and the data net will be the victim. And because of that, if there is some delay introduced in that path, then also we'll consider in the sign of stage. OCV introduced, if induced any delay, the separate delay, right? OCV is the type of OCV we have. So the delay of particular path we have to consider in the analysis models so that we will come to a more accurate model. Okay.
That's all for this video. See you in the next video. Thanks a lot for watching.